Okay, welcome back. So this lecture is on 10.5 comparison test, and it's another test that will help us to analyze infinite series. So this one will take a series that we don't know whether it diverges or converges, and we'll compare it to series that we know, right? That we know whether it diverges and converges, and based on that comparison, we'll be able to tell what's going on. Alright, so let's start with an example, with this example. So I have 1 over n squared plus 2. So I need to decide whether this converges or diverges. And the first step would be to pick a series that constitutes, that is an essence of this one, right? And you know, the way we will do it will, you know, most of the time we'll simply ignore the numbers, right? So I have 1 over n squared plus 2, so what I will pick as my sequence that I know is this one, 1 over n squared. Okay, so I know that this series converges because this is a p-series with p greater than 1. Okay, with p-series p greater than 1, so we'll conclude that it converges. So what we will do now is we'll write a couple terms of each. So let's start with this one, 1 over n squared. So for n equal to 1, I'll have 1. Then for n equal to 2, I'll have 1 over 4 plus 1 over 9, and it keeps going. Right? And I know that this one converges. So the other one will be similar. The denominator will be greater by 2. Right? So my first term, if this one is 1 over 1, this one will be 1 over 3. And then this one 1 over 6 plus 1 over 11, and it keeps going. Okay, so now we'll just look at these two series, and we can compare the terms, right? So you can see that this one, 1/3 is less than 1, 1/6 is less than 1/4, etc. So based on the fact that the terms of these series are less than the terms of this series, we'll conclude that this one also converges. Okay, and yeah, let's look at the graph of the series. So let's say this is 1, and then I have those terms 1, 2, and 3, and this is n. So let's start with this 1 over n squared. So for 1 I have 1, for 2 I have, where's 1/4? About here, and then I have 1/9. Okay, and then it keeps going down, right? The green one will be 1 over n squared plus 2. So here I have 1/3, and then for this one I have 1/6, and here 1/11. Right, so you can see that the green series is simply lower, right? The values are less. Alright, so let me write that theorem that we'll be using. So comparison test. And it goes like this. So we have two series, A n, let's call this one the first one, and B sub n, the second one. They both have to be positive series, so they cannot have any negative terms. And let's assume that an is less than bn. And this is actually needs to be positive, cannot be 0. This b sub n. Okay, so these are positive term series. Okay, so now what does it say? So if b sub n converges, then I guess I should put the sums here. Yeah, put the sums there. Also converges. To infinity, and this one the same, right? 1 equals 1 to infinity. And then if a sub n diverges and b sub n, which is greater than a sub n, also diverges, okay, and equal from 1 to infinity. Okay, so that's the theorem. Let me show you a couple examples how we use it. You see that in order to use it, right, we need to have that relationship preserved, right? So bn needs to be greater than an, right? If that relationship is preserved, right, and we know what a sub n does, right, then, well, we know that it diverges, right, then b sub n also diverges, okay, but only, we can conclude that only if that relationship is preserved. If it's reversed, right, if I know that a sub n diverges, but b sub n is greater or equal than, is less or equal than a sub n, then I cannot conclude this. Okay, I'll show you an example of how this doesn't work. Okay, but let me show you an example first how it works. Alright, so example 1, and I need to analyze something like this. So 1 over 2 and minus 1. Alright, so from 1 to infinity. So we'll compare it to like a simplified, but that's essentially what's happening here, right? A simplified version of this, which would be 1 over 2n. And then we can factor 1 over 2 out. Right? It's just a constant. Well, and then I end up with a series that I know, 1 over n. This is a harmonic series. Right? And I know that it diverges. Okay, so let's compare them. So this one is 1 over 2 and minus 1. And the other one, well, let's put that sum there. And the other one is 1 over 2n. And n equals 1, infinity. Okay, so in order to use that, right, so I know this one diverges. So for us to use that that theorem, that test, right, this one would have to be greater. Well, is it? Well, it is, right, because denominators are smaller, right? I'm dividing 1 by a smaller number, so this relationship works like that, right? So I can use that test and I can conclude that this one diverges. Okay. So I know the one that's smaller, right? So let's look at the, oh, it's right here, right here, right? So I know that this one, right, this is my 1 over 2n, right? I know that this one diverges, right, and it's smaller than the one I'm trying to find, right, that one, and therefore I can conclude that the other one, this one, diverges. Okay. Yeah, so I much I prefer the other test that I'm gonna show you in a minute. This one I find a little, can be sometimes confusing. Okay, example 2. Okay, so my series looks like this. So from n equal to 0 to infinity, and I have 4 to the power of n over 5. Okay, there's something missing. Plus 3. So what I'll do, well, I will compare it to something like this without that 3, right? So 4 over 5 to the power and the n power. So n equals to 0 to infinity. So I have 4 over 5 to the power of n. Okay. So I hope you recognize what this is. So this is geometric series. And r is less than 1. So we can conclude it converges. Okay. So maybe I'll just mark them by colors, right? This way I don't have to rewrite them. We can save some time. Okay, so let's do it like this. So red one here, green one here. Okay, so we can see that I'm adding 3 here, right? So if I'm adding 3, so this one actually is gonna be smaller, right? So the one I'm interested in is smaller than this one. So our conclusion is that it converges. Of course, in my notes I switched the colors. Let me quickly fix it. Alright. Okay. Yeah, let me write a quick note. So if I had a series that looks like this, so from n equal to 1 to infinity, negative 1 to the nth over n squared. So let me just write, we cannot use comparison test. Here, test. Here, because some of the terms will be negative. Okay. Alright, so let's maybe speed up this whole process. So example 3, right? Since you guys know what's going on. Okay, so I have something like that. So 1 over 2 plus 3 to the n. Okay, so the question is converges or diverges. Okay, so I'm going to compare it to 1 over 3 to the n. Or 1 to infinity, and here's 1 over 3 to the n. Right, and again, right, this is a geometric series, so it converges. This one is smaller, right, because of the larger denominator. So our conclusion is this series converges. Okay, maybe you guys can do one on your own. So example 4. So let's try something like this. N equals 2, from 2 to infinity, and my series looks like this. So n cubed plus 1. Okay, so why don't you guys try this on your own? So pause the video and figure it out. Alright, so I guess the hardest part maybe would be to find that, well, not in this case, later on, find the series that you need to compare it to. Anyway, so in this case I'm comparing it to 1 over n cubed. Alright, so this is a p series. P is greater than 1, so conclusion converges. So now we just need to confirm that this one is smaller, and it is, right, because you have larger denominator. Okay, so let's quickly look at this one or similar one. So from 2, we can keep that from 2 to infinity, but this time let's put minus here. Okay, so I will be comparing it to the same series, n equal 2, infinity, 1 over n cubed. But now I have a problem, right? Because these denominators will be smaller, right, than these. So this one on the left will actually be larger. And I know that this one converges, right? So this one converges. But in order to conclude that this one also converges, I would have to have this sign this way, right? So we're gonna write we cannot tell, or we're going to write inconclusive. Alright. Yeah, so that's a handicap, right, of that test, that we can only use it with positive terms, and we can only use it when the relationship, right, is preserved. Alright, so let's stop here. I'll see you in the next lecture.